How many grams of carbon tetrachloride are produced when 5.78 grams of chlorine reacts with excess carbon disulfide, assuming an 80% yield? First, take a moment to recognize that the equation is already balanced. Never assume an equation is balanced. Always check for a balanced equation. We are told that carbon disulfide is the excess reactant. Therefore, chlorine must be the limiting reactant. So we don't need to solve for the limiting reactant. Next, we want to find the mass of the product assuming an 80% yield. I explained yields in an earlier video. Here is the equation. Our strategy is going to be to solve for the theoretical yield, or 100% yield. And we know the percent yield from the problem. So we can rearrange to solve for the actual yield. I'll use the limiting reactant chlorine and convert to carbon tetrachloride. To do this, I'll need to convert the moles of chlorine to the moles of carbon tetrachloride. And I can do this by using the mole-to-mole ratio from the balanced equation. But notice, the moles of chlorine are not provided. Rather, we begin with the mass of chlorine and are asked for the mass of the product. For these problems, we need to convert the grams of chlorine to moles of chlorine using chlorine's molar mass. Once in units of moles of chlorine, we can convert to moles of carbon tetrachloride using the mole-to-mole ratio. Then we can convert moles of carbon tetrachloride to grams of carbon tetrachloride using the molar mass of carbon tetrachloride. So here it is. I'll convert 5.78 grams of chlorine to moles of chlorine using the molar mass. Then I'll use the mole-to-mole ratio from the balanced equation to convert moles of chlorine to moles of carbon tetrachloride. And finally, convert moles of carbon tetrachloride to grams of carbon tetrachloride using carbon tetrachloride's molar mass. 4.18 grams is the theoretical yield. Again, this is assuming a 100% yield. But recall that the question was asking for an 80% yield. So I'll take our percent yield equation and rearrange to solve for the actual yield. Inserting our values gives 3.34 grams of carbon tetrachloride, assuming an 80% yield. Here, propane combusts or reacts with oxygen gas to yield carbon dioxide and water. Again, take a moment to recognize that the equation is balanced. Calculate the mass of water produced when 70.0 grams of propane reacts with 90.0 grams of oxygen gas and assuming a 100% yield. No excess reactant is named and we cannot imply a limiting reactant. Thus, we must solve for the limiting reactant. There are two strategies for solving the limiting reactant, which I have explained in earlier videos. I'll choose the method where we convert each reactant to one product. Notice how there are two products. In this example, we can choose to convert each reactant to either product. But you have to convert to the same product. This is how we'll be able to accurately compare the reactants. We'll convert to water here since the question is asking specifically about water. You can pause here and try these calculations. And here it is. Notice I convert both reactants to water. Since we're interested in water, this makes the most sense. Let's take a moment to discuss the processes. These steps and concepts are described in earlier videos. First, the mass of the reactants are converted to moles using their respective molar masses. Next, the moles of each reactant are converted to the moles of water. Again, we have to convert to the same product for comparison. Finally, the moles of water are converted to the mass of water using water's molar mass. Here, oxygen gas yields the lowest amount of product. Therefore, oxygen gas is the limiting reactant and propane is the excess reactant. Notice that the reactant with the larger mass is limiting and runs out. You cannot determine the limiting reactant from the initial masses because the limiting reactant is dependent on the mole ratios. So 40.5 grams of water can be produced when 90.0 grams of oxygen and 70.0 grams of propane react, again assuming a 100% yield. How many grams of propane will be in excess? Again, you can pause here and try this calculation. Notice I used the limiting reactant O2 to find the grams of propane that reacts. Here, 24.8 grams of propane reacts with 90.0 grams of oxygen gas. Recall, there was 70.0 grams of propane initially. I'll subtract the 24.8 grams of propane that reacts. That leaves 45.2 grams of propane that remain. Let's calculate the mass of nitrogen, N2, and hydrogen, H2, required to produce 40.0 grams of ammonia, NH3, assuming a 100% and 75% yield. Notice in this stoichiometry problem, we are looking for the reactants needed to make 40.0 grams of ammonia. I also want to practice how to solve for the 100% yield and for the lower yield, 75% in this example. I'll start with 100% yield and return to the 75% yield problem. Assuming a 100% yield to 40 grams of ammonia, I'll simply convert the 40 grams of ammonia to mass of each reactant to find the exact amount of each reactant required. Let's take a moment to discuss these processes. These steps and concepts are described in earlier videos. First, the mass of ammonia is converted to the moles of ammonia using the molar mass. Next, the moles of ammonia are converted to the moles of each reactant, respectively. Finally, the moles of nitrogen and hydrogen are converted to the mass using their respective molar masses. 32.9 grams of nitrogen and 7.11 grams of hydrogen will react to produce exactly 40.0 grams of ammonia. Now, this is assuming a 100% yield. Most reactions won't have this high efficiency. What about a 75% yield? Let's go back to our percent yield equation. I can rearrange this equation to solve for the theoretical yield. Now, we know that the actual yield is 40.0 grams. This is what we're looking for. And the percent yield is 75. Inserting our values gives us 53.3 grams of ammonia that must be produced. In other words, we need to find the amount of reactant that will give us 53.3 grams of ammonia. If the percent yield is 75%, then our actual yield will be 40.0 grams of ammonia, which is the mass that the question is asking for. Here, I start with 53.3 grams of ammonia and convert to the mass of nitrogen and hydrogen. I find that 43.8 grams of nitrogen and 9.48 grams of hydrogen are required to yield 53.3 grams of ammonia. Assuming a 75% yield, my actual yield will then be 40.0 grams. 7.50 grams of silver nitrate reacts in excess barium chloride solution. 5.42 grams of solid silver chloride is measured after the reaction is complete. What is the percent yield? I'll start with the percent yield equation. This is an interesting problem because we're asked about the percent yield and the actual yield is given to us. What we'll have to do here is find the theoretical yield. The theoretical yield is assuming a 100% yield. Here is my work. I'll convert grams of silver nitrate into moles of silver nitrate using silver nitrate's molar mass. Next, I'll convert moles of silver nitrate into moles of silver chloride using the mole-to-mole ratio from the balanced equation. Finally, I'll convert moles of silver chloride into grams of silver chloride using silver chloride's molar mass. "6.33 grams is my theoretical yield. Let's go back to the problem. I'll insert the actual yield into the numerator and divide by the theoretical yield. I'll multiply by 100, and this gives me a percent yield of 85.6%.